Okay, in this video, I'm going to take a look at the binomial distribution and some ways that you might want to work that problem. So it's 30% of the visitors enter the website and make at least one purchase. And we're going to have a random sample of 8. So that 30% is the probability of success. And we're going to assume that that doesn't change over time, that it's 30% today and 30% tomorrow and so on. And that when we have that random sample of 8 visitors, that each subsequent visitor is independent of and not affected by the visitor that came before them. So anyway, calculate and graph the probability that exactly 5 purchase at least one on that item, or one item on that visit. So a number of ways we can get the probabilities here. First of all, let's just, with a table here, I'm going to look at a binomial table. The probability of successes along the top is 0.3. So that's the 30%. And each block on here is a separate probability distribution. So I'll have to go down to n is equal to 8. And you see that I've already drawn a box here. This is in the column 0.3. And this is n equal 8. And so this 0, 1, 2, 3, 4, 5, 6, 7, 8 in a sample of size 8 with p equal to 0.3, 0.0576 will be the chance that 0 will make a difference, will make a purchase. That 1, it'll be 1977. And for our question here, that it's exactly 5, we'll just read across there and it's 0.0467. On question B, it says calculate and graph the probability that 5 or more. So now you would take that 5, that 0.0467, and add to it the 0.01, the 0.0012, and the 0.0001, because those are all the 5, 6, 7, 8 are all 5 or more. Then if it said none, you would just go to 0, and it'd be 0.0576. And if it's all 8, you just go to 8, and it's 0.0001. And then it says between 3 and 5 inclusive, so you'd go to 3, 2541, and go to 5 inclusive. So you include the 2541, the 1361, and the 0.0467. Okay, so that's what to do if you have a table and really how to work them. Here's another option that you might want to be aware of, and that is that you can go to your calculator, and if you'll go into the Stat and Edit menu, if you will go to in L1 and just type all the values that you could possibly have in order there. I'm sorry, 0, 1, 2, 3, 4, 5, 6, 7, and 8. Those are all the possible values you can have for the number of people that would purchase this thing, make a purchase, and then go over and highlight L2. And now I'm going to do second distribution, and I'm going to go to the binomial CDF, or PDF, binomial PDF, and I'm going to tell it the number of trials. There are 8. Now my menu comes up like this on the one I'm using online. On my regular calculator, which is a little bit older, I just get it'll say binomial PDF and it'll open parentheses. Well, the first thing you would put in there is 8, and then hit enter. If you were doing it on just the other one, it would be just put a comma, and then you would put the P, which in this case was 0.3 or 30%. And then my X values are in list 1. So what I'm going to do is I'm going to just create the whole table there, and then just enter. And then you have to, when you get in here, you can see what it's done here. This is the command that you might see if you have an older computer. When you'd have binomial PDF, and you would have to put X, which was 8, comma, 0.3, comma, the L1, which is where the values for X are at, and then just hit enter. And that's going to fill in the same values that we had in the table here. So if you don't have a printed table with you and you have a calculator, you can make your own table right in there. So that's number 2. You've got it with the table and with a calculator. So now I want to show you a couple of online tools you can use. This one, and I'll have the link to that on the website and on Blackboard if you're in my Blackboard class. N was 8, P was 0.3, and X was 5. And let's see, yeah, we're just doing equal there. And you'll see that that probability comes out to be 0.04668. Now on the table that was 0.0467, so it just rounded there. And you can see it's drawn a little graph here where you have, there it is, 4 or 5 is shaded in this, I call that a rose color or pink or something like that. Anyway, that is one way to graph. And of course you could then, if you have a screen capture, just screen capture that. Might use the snipping tool in Word, and then you can just copy that into your homework. Okay, so here's another one, another package, and again I'll have or another link to an online calculator. We had 8 trials. We had 0.3, and then you can calculate the table, and this first bit here is the values of X and their corresponding probabilities. I think you'll find that those, with the possible exception of some rounding, are exactly what we got with the calculator or the table or any other way. It also has a cumulative, less than or equal to, or a cumulative going the other one, greater than or equal to. That's kind of a handy thing to have at times. It also has a graph there. That didn't show up very well on this. So it graphs the distribution. Now you'd want to, in something you turned in, I guess circle or indicate in some way the values of X that were of interest, in this case equal to 5 or 5 or more. And then finally, get this over here, we can do this in R. And this is a program that, some code that I wrote. It's not, doesn't have everything on there I'd like for it to have maybe. Of course, one thing I'd like for it to do is be all on one screen so you guys can see it. Give me a second here. There we go. So I have this R code that will obtain and graph probabilities for you. So I'm just going to go in and enter the 8, the 0.3, and I want to go from, let's say if I just want to go to 5 to 5, that would just get me 5 only. And then I will say, if you look through this, and you'll have to just read through here, that you have to go down and change the title here on your graph and just put the right values in for N and P. And then you can just highlight this and run it, and you will see that not only do we have a binomial distribution graph, I have the whole thing, and then I've already highlighted the one that we asked for, the 5, and okay, then here is the binomial table. My code's got that. And one other thing I could have done that would have been good, I think. Actually, I'm probably going to change the code so you don't have to do this, but right now I'm going to put 5 to 5 right there. And if I run that, that's going to give me that probability of 0.0467. Okay, left there for a second. I have changed the code now, so now whatever you put up here for 5 of 5, it'll automatically, the last thing that'll come up, the table, and then it will actually compute that probability for you. So on the next question, I believe it asked 5 or more, and so if I went back to my code now and changed this to 8, because it can only go up to 8, highlight and run everything. Now it's added it up, and you can see it's changed the shading. And of course, you can just export and copy to clipboard and copy that plot on into anything you turn in. So there are some options for you for making the graphs and getting the probability distributions and doing some calculation. I guess the last thing I should add here is if you don't want to use one of the graphs like the one on R here, which is actually probably the best one, but I guess that can be your call. You can always just draw the thing by hand. So if you were doing this one here and we had our x's can be 0, 1, 2, 3, 4, 5, 6, 7, and 8. And then, let's see, our probabilities go to about 0.3. So we've got 0.05, 0.1, 0.15, 0.2, 0.25, and 0.3. I'm hoping to convince you that it's worth using one of the R or one of the online packages to do this. So we had for 0 about 0.057. I should have drawn that over here a little bit. And then for 1, about 0.2 almost, 0.197. I'm reading these right over here off of my probability distribution. Then for 2, 0.297, 0.25 about, and then 0.13 with the 4, and then about 0.05, then just 0.01, and then the other ones are really just small there. And if you were looking at then if for 5 or more, I might just go ahead and make those another color. And then you could copy that and put it into your solution. Okay, that'll be it for this video.